Sir, can I start, sir? Hello. Sir, can I start, sir? Ramarao, sir. Very good evening, children. Hearty welcome to the TRICE webinar classes. It's intermediate first year, Maths 1B, coordinate geometry session. Today's topic is locus. Myself is SUHASINI, Principal FSC, TSRS&JC Girls, BODHAN at Edapalli. Dear children, let us have a glance at the introduction of today's maths class. In school mathematics, we learned about some elementary concepts of analytical geometry. This branch of mathematics is also known as coordinate geometry, which utilizes the idea of geometry and algebra. Geometry and algebra. Dear children, I would like to devote the first few minutes to make you understand what this concept is. In geometry, we do constructions and we read the property of many figures. And in algebra, we talk about the equations, expressions. Now, combination of these two branches of mathematics is a beautiful topic, which is coordinate geometry. So coordinate geometry is the fusion of geometry and algebra, two magnificent branches of mathematics. Here, whatever you see, that is describable in a language of mathematics. And whatever we describe can be seen as a figure. That is coordinate geometry. More clearly, if I take x-axis and y-axis, suppose if I draw a point here, what do you say, children? Origin, and it is addressed as O 0, 0, O 0, 0. That is, in geometry, we have described a point. In using algebra, we are giving a particular address. Are you following my point, children? Also, in geometry, now you have drawn an axis. This is x-axis. Now, you give this name as x-axis, whose equation is y is equal to 0. This you might have studied in your 10th class. And this is the y-axis, whose equation is x is equal to 0. Whose equation is x is equal to 0. We'll learn more. And this is parabola. In 10th class, you might have studied whose equation is ax square plus 2hxy. So, ax square plus bx plus c equal to 0. So all these figures, whether it is x-axis, whether it is y-axis, or a point, or a curve, or any geometric figure comes under geometry. Okay, their diagram comes under geometry. And its address, whose notation is given in the form of O0, 0 in this particular case, x is equal to 0, or y is equal to 0, or ax square plus bx plus c is equal to 0 is algebra. Now, have you followed? And this unification is coordinate geometry. So it's not purely about the figures, or it's not purely about the equations and expressions. It's a fusion of those two topics. Now, our intermediate mathematics 1B is divided into two parts. One is coordinate geometry and the other is calculus. Now, our present chapter, Locus, is part of coordinate geometry. Locus is the first topic in coordinate geometry. In the intermediate maths 1B question paper, we have short answers questions, very short answers questions, and long answer questions. 3 categories. Very short answers, long answers. Very short answers carries 2 marks. Short answers carries 4 marks. Long answers carries 7 marks. And today's topic, Locus, is of weightage 4 marks, is covered under short answers category of our intermediate question paper. Dear children, let us observe the figure. We shall discuss more about such situations. Just have a glance at the figure, children. We have a center point as a circle and an arrow measuring approximately some distance, suppose 5 centimeters. Now, I will draw a point. Now, I will draw a point here at a distance of 5 centimeters. For example, it can be 5, it can be 4, it can be 6. In this case, I'm taking. So let us take a point P. Where is the point P, children? The point P is at a distance of 5 centimeters. How many centimeters? 5 centimeters from a fixed point C here. But dear children, is it the only point that exists in the plane which is at a distance of 5 centimeters from C? I repeat the question. Is it the only point that is at a distance of 5 centimeters from a fixed point C? No, there are many points. For example, from here also I can take a point. Suppose it is, if it is P1, I can take here P2. And this distance might also be 5 centimeters. Like this, here, like this, here, like this, here, like this, here. I can collect many points in the plane which are at a distance of 5 centimeters from this fixed point. Are you all following, children? So I'm talking about the collection now. What am I doing, dear children? I am talking about the collection. I'm collecting. What am I collecting? Like you collect some pebbles when you walk on the seashore, shells you collect. So I'm collecting points here. I'm sorry, we are collecting points here. We are going to collect the points. But not all the points which we like. Not all the points which we like. The points which follow some condition. Okay, in a plane, we have infinite points. Out of all those points, we are talking about the collection of some points. Is it clear, children? So I am collecting all those points and tracing them with the pencil. And let us see what geometric figure we get. It's a circle. It's a circle. Have you seen the figure, children? Because it is a circle, it's a geometric figure, isn't it, children? Circle is a geometric figure, whether it is 2D or 3D, planar, let us discuss later. But it's a circle is a geometric figure. In this chapter, Locus, we are going to talk about such a collection of points and tracing and such geometric figures, what we get, and their equations. I repeat, this chapter, Locus, is all about the collection of points. Which points? The points which follow a particular rule. And after collecting, we shall see the path followed by them. We shall trace and find out the figure, and we give suitable equation for such kind of geometric figures. Hope you all followed. This is a motivation slide for your class, children. Let us enter to the class. This unification, that is unification of geometry and algebra, is coordinate geometry. This unification is very well illustrated through the concept of locus, and is about which we learned little in the class 9. Hope you all have understood little about the class in the class 9 about the locus, children. You are familiar with this topic. It's not new. In mathematics, we always learn the concepts from knowing to unknowing. So we learn higher concepts starting from the concepts you have already known in your previous classes, in your school ages. Dear children, in 9th class, we studied some patterns formed by points in a plane, satisfying certain condition or conditions, isn't it? Some patterns. Till now we have seen a slide. What was the pattern we observed, children? It was the circle. Like that we have observed a straight line. You might have observed any other, like a parabola, any other geometric figures. We get different patterns. These patterns, the shape of the patterns depend upon the collection you're taking. Is this clear, children? Let us recall such patterns lead to the concept of locus in this class, children. Before going to start our actual class, I would like to tell you the importance of the locus and the mathematician who devoted much of his life for the development of these concepts. Importance of the topic. The mathematicians knew about the conic sections. Conic section is the figures formed from the conic after cutting in different shapes that you learn in your second year, children. And these conic sections are the geometric curves. What are these conic sections? These are parabola, ellipse, circle, etc. What are all these? These are geometric curves. This knowledge is several centuries before, but it was Kepler who showed the application of this curve at cosmic level. These geometric figures have the greater applications at cosmic levels in the space. Speaking more specifically, his laws of planetary motion magnificently display the loci of planets as elliptic curves. Before Kepler laws, we have a notion that the path of orbits is a circle, but taking the locus, the knowledge of the locus, Kepler proved that planets revolve around the sun in an elliptical way. And the great revolution in the field of science has started from that. So our locus is a basic for today's science and technology. And the knowledge of this science, this chapter locus helps you to understand the concepts in your second year also. Locus is a small chapter in your first intermediate, but it has got a wide application in second year and in latter mathematics. So I request you all to pay the highest attention to the class and work on everyday's class so that you can better understand the concept. Rather than the marks, the knowledge is important. You need to work for marks also, but knowledge of the topic is more important for your successive chapters, successive class also. Let us see the definition of the locus, children. Locus is the set of points. Set of points in the sense, collection of points. Set is nothing but collection. Which collection is called set? The well-defined objects, if put together, is called a set. You cannot collect everything what you want and call it as a set. You have to collect the elements which follow a certain rules. And only those points should be there, not unnecessary points. And only those points. Locus is collection of points. Collection, which collection? A collection that satisfies the given consistent geometric condition. Suppose in the previous example, I was talking about a point C, and I was asking you to observe the points which are at a distance of 5 centimeters. Okay, and I have collected all those points and I have showed that the path is a circle. Isn't it, children? We observed that in that case, the path was circle. If I say you take the point C and collect the points which are at a distance of infinity. Can you do it in your present class, children? You cannot collect like that. So we cannot talk inconsistent geometric conditions. You can talk the conditions which are consistent. Collect all those points which are consistent geometric conditions. Which satisfies the consistent geometric conditions. And those points collection is called locus. So locus is all about the points and its path. So you have to remember two important points. What is that? Locus is about the points. And which points? The points which follow a geometric condition is the point number 1. And point number 2, the points follow condition. Which condition? Consistent geometric condition. Is this clear for you all, children? This is the definition of the locus. After after looking at the definition, we understand 2 important points. One is, every point satisfying the given geometric condition is a point on the locus. We are talking about the points. If a point satisfies the geometric condition, it lies on the locus. And every point on the locus satisfies the given condition. Let us talk more about these 2 important points now, dear children. I'll take the same example till you understand the concept of locus better, children. In next slides, we talk about the many examples, but at present, I would like to stick to circle, because circle is a closed, beautiful figure. It attracts many minds, like moon, sun, those appear as a circle. Your mother's bangle and your mother's sticker. Everything in the nature, the many of the beautiful objects in the nature or in the circular form. And circle has some wide applications of attracting young minds like you people. Okay, so I am sticking to circle. Dear children, let us take a point C, children. It is a fixed, I'm not going to disturb it. And now, I'm taking another point which is at a distance of 5 centimeters. From C. Then what shall I get? I shall get a point P. Isn't it, children? Like that, I shall take the point here. Another point P1. Suppose it is P1. And then it is P2. And then here 1 point. And then here 1 point. Now let us trace all these points. Like this, we get many points. In the previous slide, you have seen, children. When we trace, it's a circle, right, children? So locus of this condition is a circle. Observe another figure, children. Observe another condition. I will take another point now, R, which is at a distance of 10 centimeters, for example, not 5, more than 5. Where will be that point? Outside. So when it is not satisfying the condition, when R is not satisfying the condition, the point will not lie on the circle. The point R lies outside the circle. Not only 10, children. Consider the 1 centimeter point, the point which is at a distance of 1 centimeter from the fixed point C. Suppose name it as Q. Where is Q? Is inside the circle. So the points which are not at a distance of 5 centimeters are not on the circle. Maybe outside or maybe inside, but not on the circle. Is that clear? And if a point is on the circle, suppose this point I'm taking. And what is the distance of this point from the center? 5. If I take this point, it is also satisfying a condition that it is at a distance of 5 centimeters from C. If I take this point, it is also 5 centimeters. So, you take any point, that point must be on the locus. If and only if it satisfies the given condition. If the distance CP is equal to 5, only then point lies on the circle. If point lies on the circle, then it must satisfy. Then it must satisfy. Every point satisfying the given condition must be on the locus. If any point, if you have any point on the locus, then it must satisfy the geometric condition. If geometric condition is satisfied by the point, then it must be on the locus. These are the very, very 2 important points, children. If any person is there in your family, he is your family member. isn't it? If he is your family member, if not in the family, take the surname. If any member having the same surname of your family is your family member. And if he has your family member, he has a surname. If he has a surname, he is your family member. Isn't it, children? Like that. If and only if. Let us see some examples so that you can understand better, children. In a plane, the locus of a point whose distance from a given point A is 5. How to write the solution in your intermediate is like this, stepwise solution. Any point, now we are talking only about the locus. We are not talking anything more than the locus. In the first class, what we are doing is, we are talking which geometry figure we may get. That analyzation we are doing, that's all. Nothing more than that, children. Any point which is at a distance 4, here it should be 5, children. Phi from A lies on the circle of radius phi with center A that we have seen so far. Conversely, every point on the circle is at a distance of phi from A. Hence, the set of all points on the circle is the locus in this case. So locus, what is locus in this case? What is your final answer? Is a circle. What is the geometric figure? Circle. Which circle? The circle with center A and radius, sorry, it's phi. Is it clear, children? Like this you have to write when it is only locus. Just he is asking us to find the locus. Again, let us see that motivational slide. This is the point, see, children. And now I am collecting all the points which are at a distance of 5 centimeters from this fixed point. When I am collecting, what is the geometric figure I got, children? Is a circle. Let us take the second question, second example. The locus of a point equidistant from 2 given points A and B. What was the previous question? Please pay attention to the question, children. In a plane, the locus of a point whose distance from a given point A, only single point. Our point is at a distance of 5 centimeters from the given point, only single point. But in this case, the locus of a point equidistant from 2 given points A and B. Is this clear? It's the difference between the previous example and this example. Let us discuss it through an activity. Let us take a line segment joining the points A and B. Now we have to collect the points. In the previous slide, we have collected like this. Now also we have to collect the points. Which points to be collected? The points which are at equidistant from both A as well as B. How can we do it? Please remember the construction that you have done in your previous classes. If it is equal distance or any construction we do with compass, right, children? Let us take some radius R, and from A we draw arc, from B also we draw arc above the straight line. With the same radius, without disturbing the compass, let us draw arcs below the line segments. And these 2 points now, the points of intersection of these 2 arcs are equidistant from A and B. Let us collect all those points. What is the figure format, children? It's a straight line. Straight line with some additional qualities. Which straight line? The straight line which is perpendicular to AB and which is bisecting AB. Hence, the locus in this case is a straight line which is also a perpendicular bisector of the line segment AB. This is the locus in the present case. Perpendicular bisector of the given points AB is a locus. Let us take another example, children. Locus is the collection. Locus is the figure that is formed on the collection, is the present aim of the class, children. You only concentrate on the figures. Third question, children. The locus of a point above the x-axis, whose distance from the x-axis is 3. Locus, in the sense, now we have to find the points. Which points? The points which follow a rule. Which rule? All the points what we are going to see now must be above the x-axis. The points in the plane can be above the x-axis or below the x-axis, isn't it, children? But here we have to collect only the points which are above x-axis. Above x-axis, that must be underlined. But above x-axis we have infinite points, isn't it? Then which points above the x-axis? The points which are at a distance of 3 units from x-axis. Only at 3 units. Now it is easy for us. It should be consistent, dear children. Hope it's clear for you all. Now we are going to take a graph sheet in which we draw x-axis, y-axis, and then mark the points. Which points? Now it is a 2D plane, isn't it, children? In this plane, which points are going to be collected? The points which are at a distance of 3 units above the x-axis. Look at the points. Are they at a 3 units distance? Yes. 1, 2, and 3. Yes. Are all these points above the x-axis? Yes. Like that, you mark so many points, as many as you can, and join them. And join them. This is the collection of points. These are examples. Like that, you will get infinite points above here in the straight line in both the directions. Unlimited. Okay, let us join all those points. Joining is represented by blue line. What is this? It's a straight line. Which straight line? The straight line parallel to x-axis. And is at a distance of 3 units from the above x-axis. 3 units from the x-axis. Therefore, locus in this case is also straight line. Hope you all have understood. So, in the view of above examples, locus of a point in the plane is generally a curve in the plane. Isn't it? A curve. Curve in the sense a geometric figure. And we call that curve itself as locus. The name of that curve itself is the locus. The locus in the example 1 is a circle. In the first example, what is the locus? What is the geometric figure? What is the path of the points? Any name you can give. It is a circle in the first example. In the second example, is a perpendicular bisector of the line segment. But it's a line, isn't it? Which line is secondary? But what is its name? It's a straight line. Similarly, in the third case is also a line parallel to x-axis, above x-axis at a distance of 3 units from it. Isn't it, children? So, whatever may be the line, but it is a line. So, in the first case, it's a circle. In the second case, it's a straight line, as well as in the third case also, it's a straight line. Like that, depending upon the rule asked, or rule imposed by the points, we get the different geometric figures. So, in this chapter, we are going to learn many more properties and equation in Locus chapter. Let us learn all those concepts tomorrow. And today, your homework is just open your Intermediate Maths 1B textbook. And before talking this locus, you have an exercise, prerequisites, that to be exercised, and read the definition of locus and understand whatever the 3 examples I have quoted now are taken from the textbook. Just go through the textbook at your own pace. And this mental exercise is very, very needed to understand tomorrow's class, dear children. And before stopping class, I would like to take you all to a beautiful application of mathematics. I would like to explain the concepts in in a mathematical app called Geogebra. This is the Geogebra application, children. When I was talking about the coordinate geometry, I have said that whatever we show is labeled. See, dear children, look at the screen. Now, the mouse is placed at a point A and is at a blue color like a dot. So it is a geometric structure, but its address is shown by capital A, 1, 0, which is nothing but algebra. Look at the left side of it is A, 1, 0. And this is the corresponding point. So point is the geometry and description below it is algebra, fusion, coordinate geometry. Look at the point B, 2, 0. So whatever you show or whatever you mark is written there. See, it is x-axis. The line name is x-axis, whose equation is y = 0. And you have F, you have G, H, I, J. It's a collection of the sum of the points. This is a collection. And if I join these points, what is you're getting? It's a straight line. Which is straight line? A line parallel to x-axis and is at a distance of 3 units. So in this case, it is a straight line. Locus of the points which are at a distance of 3 units above the x-axis is a straight line. And this straight line equation is y = 3. How the equation y = 3 can be explained in tomorrow's class. And before starting to that, let us go to next example. Dear children, I have taken a point A in the plane and I have chosen another point B. Look at the screen, children. B is at a distance of 5 units. It is F. F is at a distance of 5 units. Now, let us trace the path. Are we only tracing or is it true? Let us do it scientifically. Let us check its path. If I am taking all the points, see in what direction it is starting? When it is moving, what is the path? Circle. It's collecting all the points in this direction, isn't it? Can you see the points? What are those points? Look on the x-axis, children. All the points are at a distance of 5 units. Look at the y-axis. Which points we are taking? Look at this point. C point. Look at the point D. Look at the point E. Look at the point F or any point in this circumference. What is the distance? Tell me. What is the distance of this point from A? Is 5 centimeters. Is only F. F is not changing, isn't it? So it's a collection of all the points which are at a distance of 5 centimeters from A. The second important point I would like to take is, I would like to take any other point in the plane which is not on the circle, and then I would like to tell you that G, look at the distance G, children, it's 8.6. That means K is not following a geometric condition that the distance of this point from A should be 5. It is not following the rule. Then where is K? Outside. If it is not following the rule, it should be outside the locus. But Observe all the points which are satisfying the rule. Where are they? All the points which are satisfying or on the circle. If I take any other point inside, now in this case, let us take inside. Now observe the distance. H, what is H? 2.24, which is less. Whether it is less or more, but not equal. Hence, the point is not on the locus, is what I wanted to explain, children. Hope you have understood. So if a point is on the locus, it must satisfy a rule. If it is satisfying the rule, then point must be on the locus. Is it clear, dear children? Let us take another, I'm sorry. Let us take another example. I have a point A and another point B. These are two are fixed points, children. I'm fixing these 2 points. Now I'm taking a point C, which is equidistant from both A and B. Okay. Point A is minus 3, 0. Point B is 3, 0. And C is 0, 4. If you observe, these 3 are equidistant from the point. See, it is on y-axis. And these 2 points are on the same distance from origin. Hence, you can understand, or you can measure with the scale on your graph paper, or you can do the construction, dear children. This improves your analytical power. Okay, due to the lack of time, I'm unable to show now drawing. Let us see what is the path. C is the point which is equidistant from A and B. Isn't it, children? Let us take many more such points. Many more such points which are at equidistant from A and B. See, these many points are equidistant from A and B. Collect all those points. What is this figure? This is the straight line. Which is straight line? It is a y-axis in this case. And AB is a part of x-axis. Hence, y-axis is perpendicular to x-axis. So, present locus is a perpendicular bisector of the line segment AB. See the distance 0, 3 units. Here also it is 3 units and is perpendicular. Hope you have understood better. And please listen all the classes carefully and complete all your homeworks on that day itself. And please approach your class teachers or subject teachers through proper channel for more clarifications of your subject. Have a great day, children. Happy learning.